Agent security starts with a simple rule. Give the agent only the access required for this user, task, session, environment, and risk level. In this module, we'll turn least privilege into a practical design pattern for safer autonomy. Up to this point, you've built the security mindset for agents. What makes them risky, how to threat model workflows, how weak boundaries fail, and why tool access is the critical gate. Now we turn that mindset into design practice. Permissions that allow only the needed capability for the right user in the right context. Least privilege is the safety boundary that keeps one bad agent step from becoming a major incident. Instead of giving the agent every tool the application or developer can access, permissions are narrowed by context: who the user is, what they are trying to do, what the task requires, and how risky the environment is right now. Access should also be temporary, visible, easy to revoke, and logged. That way, if reasoning goes off track, a prompt injection succeeds, or a session is compromised, the blast radius stays small. Good permission design is multidimensional. Start with the user. What is this person actually entitled to do? Then add role. What does their job function normally require? Next, narrow by task. Which tools are needed for this specific workflow step and which should stay locked? Finally, evaluate the session and environment. A trusted device in production may get different access than an unknown device on a risky network. The key model is intersection, not addition. The agent should act only when the user, role, task, and context all agree that the action is appropriate. A safe agent does not get its own unlimited authority. It acts through the user and through the role assigned to that user. A finance analyst can reach budget, report, and payment tools. An HR partner reaches employee and leave systems. An IT engineer reaches systems and access management. The important control is delegated least privilege. The agent can do what the person is allowed to do and nothing more. Avoid shared super agent accounts. They bypass user permissions, blur accountability, and turn the agent into a privilege escalation path. Task-based permissions begin with intent. Instead of giving an agent every tool it might ever need, match the current request to a narrow bundle. Summarize a ticket, retrieve an invoice, update a CRM record, or draft an email. Each bundle contains only the capabilities required for that workflow. Read access stays separate from write, delete, payment, deployment, and communication rights. If the task changes, check permissions again. And when the agent moves from low-risk analysis to high-risk execution, it must explicitly escalate before stronger tools become available. Permissions should not be fixed just because an agent has a role. The same agent may deserve broader tools during a fresh MFA-verified internal session, but very limited tools from an unknown device, suspicious IP, or anonymous public flow. The deployment environment matters too. Development and staging can allow experimentation, while production, customer-facing, and regulated systems require tighter controls. A permission engine should continuously combine identity, session, device, network, and environment signals into a risk decision. As risk rises, reduce tools, lower rate limits, and require stronger approvals. Never let production inherit test credentials or experimental privileges. A safe agent treats tool use as a request, not a right. The model can reason, plan, and propose an action, but a separate permission layer makes the authorization decision. That layer checks the user, role, task, session state, environment, tool risk, and exact arguments being passed. If policy allows it, the action proceeds to the tool or API. If not, it fails closed, returns useful guidance, and records an audit event. Keep these policies explicit, versioned, testable, and observable, so decisions are consistent and debuggable. Credentials should work like disposable task permits, not permanent keys. When an agent requests an action, the system first authorizes the exact scope: which resource, which operation, which user session, and which environment. Only then is a token generated just in time, with a short time to live, such as 5 minutes. The agent calls the tool using that token, for example, CRM read, customer_123. After use, the token expires automatically, or can be revoked immediately if behavior looks suspicious. Every use is logged, making access limited, traceable, and easier to audit. Backend calls are where many agent designs accidentally become overpowered. A single shared service account is convenient, but it turns every task into broad standing access across tools and data. Delegated authorization changes the model. The agent authenticates as a machine, but receives authority tied to the user, the task, and policy, often through scoped tokens, constrained impersonation, or token exchange. That keeps access minimal, temporary, monitored, and auditable. Keeps service accounts narrow, non-interactive, and governed, so convenience never outruns control. Secrets are something the model can use indirectly, but never see. The prompt, chat history, retrieved content, logs, and tool responses are all part of model context, so they must be treated as untrusted for credentials. API keys, database passwords, refresh tokens, and signing keys belong in a secrets manager or credential broker. The LLM should ask for an action, like send this request, while trusted runtime code injects the credential and returns only the safe result. Sanitize failures too. No environment dumps, stack traces, or leaked config values. Every tool has a blast radius. If the agent is tricked, how much can it damage? Reduce that radius with least privilege. Build specific tools for specific jobs, not one tool that can touch everything. Bind each tool to allow datasets, accounts, regions, resource IDs, or business domains. Then add guardrails, rate limits, quotas, transaction caps, and time windows. The goal is not just preventing failure. It is making any failure small, contained, auditable, and easy to recover from. An all-in-one tool is convenient, but it creates compounded risk. If the agent can read, edit, delete, and send data through the same permission path, one mistake can become a breach. Safer catalogs separate capabilities by consequence. Reading should be lowest privilege and read only. Writing needs stronger authorization, validation, and change logs. Deletion, payments, deployments, and other irreversible actions deserve isolated tools and extra approvals. External communication is equally sensitive because it can leak data through email, Slack, webhooks, or HTTP. Separation makes controls more precise and audits clearer. Least privilege limits what an agent can access, but it does not make every allowed action safe. For high-impact tasks, the agent should propose the action first, then classify the risk. Before anything changes, run a preview, dry run, or diff, so a human can inspect the expected outcome. If the risk is high, require explicit approval, then execute with a short-lived scoped token. Design the operation to be reversible whenever possible, using undo, rollback, quarantine, or delay. Finally, log who approved what, including parameters, timing, and outcome. The core lesson is simple. Agent tools should never be broadly available by default. Permissions must be contextual, temporary, and tied to identity, task, session, environment, and risk. Keep secrets out of prompts, separate dangerous actions, and add approvals, logs, and rollback paths. Next, we'll strengthen this boundary with secure argument validation and sandboxed execution.